So today's lesson is about solving rational equations. So by the end of today, you should be able to say, I can solve rational equations and I can identify extraneous solutions in rational equations. So this first statement here is a rational equation. So is an equation that contains one or more rational expressions. So we're going to write rational equation here in the blank. So when we're solving a rational equation, we're going to start by seeing if anything factors and cancels. If not, then we're going to start by multiplying each term of the equation by the least common denominator of all of the expressions in the equation. This step eliminates the denominators of the rational expression and results in an equation you can solve by using algebra. So we're going to do exactly what those instructions told us to do. We're going to factor the numerator here, put it over our denominator. So what are the factors of x squared minus 25? X and x here, 5 and 5 here, and plus and minus. Then we're going to scratch through what is both in the numerator and the denominator because it cancels out. We're left with x plus 5 equals 14. And then we're going to subtract the 5 from both sides. So x is equal to 9. Now, extraneous solutions mean that when we plug an answer back in, it's false. Well, in this case, the only thing we have to do to find these is look at our denominator. So we're looking at this number right here. So we're going to do x minus 5. We're going to set that equal to 0. X cannot equal 5. Well, x equaled 9 here, so that's definitely not an extraneous solution, okay? So we're going to do the same thing here that we did with the other one. We're going to factor the numerator, put it over our x minus 2 equals 7. So again, we got an x and an x. What are the factors of negative 10 that when added together give us a positive 3? Obviously, we know one's going to be positive, one's going to be negative because it's a negative 10. So only factors of 10 are 1 and 10 and 5 and 2. So this would have to be a positive 5 and a negative 2. Here again, we're looking for anything that's in the numerator and the denominator to cancel out. So we get x plus 5 equals 7. X, when we subtract 5 from both sides, equals 2. Well, here again, we're going to set our denominator equal to 0. So we've got x minus 2 equals 0. So x cannot equal 2. Well, x equals 2 down here. So what does that mean? That means that this is an extraneous solution. Which means this problem has no solution. Because the one solution it does have is extraneous. So I'd like you guys to go ahead and solve this and then come back to me when you're done and let's check it. So here we go again. We're going to factor the numerator, put it over our denominator. Okay. So what are the factors of negative 12? So we know that one's going to be positive, one's going to be negative, right? That when added together give us a positive 1. So that would be 4 and 3. Once again, our 4s are going to cancel out. So we're going to get x minus 3 equals negative 7. Add 3 to both sides. So x is equal to negative 4. So we want to check again for our extraneous solutions by setting this equal to 0. X plus 4 equals 0, so x cannot equal negative 4. Again, notice right here it does, okay? So what does that mean? This is an extraneous solution. So there is no solution. Go ahead and do this one as well, and then come back to me when you're done and check your answer. So here we go again. We're going to factor our numerator. That's going to give us 2x and 2x and 3 and 3 plus and minus. That's over 2x plus 3. We're going to set that equal to 5. So here again, we have a 2x plus 3 and a 2x plus 3, so this is going to be 2x minus 3 equals 5. Add 3 to both sides. 2x equals 8, divide by 2, so x is equal to 4. So we're going to go ahead and plug that 4 in up there just to double check and make sure. But I pretty much know because it in the denominator, we're going to set that denominator equal to 0. 2x plus 3 equals 0. Subtract 3 from both sides. 2x is equal to negative 3. Divide both sides by 2. So x cannot equal negative 3 over 2. So here again, those are different. So this is our solution. Okay. So with number 5, I'm going to rewrite parts of the problem first. So I'm going to do p minus 1 over p plus 3 minus, and then the 2 p minus 3. And then I'm going to set this equal to 7 minus 3p over. And I'm going to go ahead and factor this right here. And hopefully you remember this is going to be p and p. And that's going to be 3 and 3 and plus and minus. Okay, so now when we're looking, we got to get a common denominator for all this stuff, guys. Okay, so what we're going to do is we're going to multiply this over here by the denominator here. So we're going to do p minus 3 over p minus 3. And then we're going to do the same sort of thing over here, only with p plus 3 over p plus 3. Now we have a common denominator for all of it. Notice that this is the same as this is the same as this. So what does that mean? That means now we can just solve the top part of this problem. Once everything has a common denominator, we can solve just the top. So that's what I'm going to do now. So I'm going to do p minus 3 times p minus 1 minus 2 times p plus 3, and then I'm going to set that equal to 7 minus 3p, right? So this is going to be p squared minus p minus 3p plus 3 minus 2p plus 6 is equal to 7 minus 3p, okay? Keep on simplifying. P squared minus 4p plus 3 minus 2p minus 6. That's a common error right there, y'all. Okay, so because that's a minus, it's going to change both these signs. Okay, so really watch that when you're doing it, all right? So this is equal to 7 minus 3p, okay? So, excuse me. Now what we're going to do is we're just going to simplify. We're going to keep simplifying the problem. So we've got p squared, then these are like terms, so that's going to be minus 6p. And these are like terms right here, so that's going to be minus 3. Actually, let me do that in the same color I was working in. So that's going to be minus 3 is equal to 7 minus 3p. So then we need to move these. So that's going to be minus 7 plus 3p plus 3p. So that's going to give us p squared minus 3p minus 10 equals 0. So what we need to do now is we need to factor this. Okay, so I'm going to move it up a little more so I have a little more space to work with. So we're looking for the factors here. So that's going to be p and p. Again, we're going to have a plus and a minus because that's a minus 10. So this time we're going to have plus 2 minus 5. Sorry, that's supposed to be a 0 right there, y'all. I don't know why I wrote 10. I guess I wasn't thinking. We moved the 10, right? Okay, so then we're going to set these equal to 0. So p plus 2 equals 0. So p equals negative 2. And then we got p minus 5 equals 0. So p is equal to 5. Now, we're going to go back up here at the top, and we're going to see if either one of these were excluded values. Well, when we look at our common denominator, that's what's going to determine. So where's our common denominator? It's over here in green. Y'all see this common denominator right here? Those are the two things that we're going to see those are going to be our excluded values, okay? So we're going to do p is equal to 3. Can't equal 3? No, p cannot equal -3. Why? How did we do that? Because p plus 3 equals 0, so p cannot equal -3. And then p minus 3 equals 0, so p cannot equal 3. Okay? Well, neither one of those, neither the -2 nor the 5 are those, so that's our answer right there. Okay? So as we start working through this problem, I'm going to work through it like I did the other one. And again, we're going to set that equal to what we have over here, 3x plus 4. We're going to factor what's in that denominator. And again, we got a plus and a minus, so it's going to be plus 3 minus 2, okay? Over here, we want to get our common denominator again, okay? So when we do that, that means we're going to have to multiply the top and the bottom over here by x plus 3 and x plus 3, and this one by x minus 2 over x minus 2. So now notice we have a common denominator everywhere. So this is the same as this and this. So I want to also bring to y'all's attention that at this point I could say what our excluded values are, because I could say x plus 3 equals 0, so x cannot equal -3. X minus 2 equals 0, so x cannot equal 2, right? So those are going to be our excluded values, which would mean if we get one of those for our answers, then that's going to be the extraneous solutions. So now what we're going to do is we're going to do what's on the top. So we're going to solve using our numerator, right? So we're going to do this stuff right here. So that's going to be x plus 3 times x plus 2 times x minus 2. And that's going to be 3x plus 4. So all we have to do now is simplify, right? This is going to be x squared plus 3x plus 2x minus 4 equals 3x plus 4. Combining like terms, x squared plus 5x minus 4 equals 3x plus 4. I'm going to subtract the 3x from both sides. And we're going to subtract 4 from both sides. So that's going to give us x squared plus 2x minus 8 equals 0. Then we have to factor that. So that's what we're going to do next, is factor that. So again, x and x, we know that there's going to be a plus and a minus because it's a -8. So it's going to be plus 4 and minus 2 equals 0. So then we're going to set these equal to 0. 0 equals x plus 4. So -4 is equal to x. And then x minus 2 is equal to 0. So x is equal to 2. Well, look here. We have the same value there and there. So what does that mean? That means this is an extraneous solution. And this one is our solution. Okay? So this last concept takes us back to probably late elementary school, early middle school, when you guys were cross multiplying here. When you got an equal sign in two fractions, this is how we solve, right? So we're going to do x times x minus 2, and that's equal to x minus 4 times x plus 10. Again, our excluded values here would be, if we were talking about extraneous solutions, x minus 4 is equal to 0, so x cannot equal 4. X minus 2 equals 0, so x cannot equal 2. So let's go ahead and solve this. X squared minus 2x. Then we're going to do this, x squared plus 10x minus 4x minus 40. Continuing to simplify as we work through this problem. Plus 6x, because we subtracted. Those are like terms right there, y'all. Now we're going to subtract x squared from both sides, which means boom, that's gone. Then we're going to subtract the 6x from both sides. So that's going to give us -8x equals -40. Divide both sides by -8. So x is equal to 5. And that was not one of our excluded values up there, so that is the answer. And you could put it in there and double check it just to make sure you got the right answer. Here's our last one, and we're going to do the same thing. Cross multiply here. So I'm going to do 5x times 7 is equal to 6 times 4x minus 3. And again, what were our excluded values? We would set this 4x minus 3 equal to 0. So 4x equals 3, because we added 3 to both sides, divide both sides by 4. So x cannot equal 3/4, and it did not. So that was our answer right there.